Over 400 million years ago, Earth's primordial oceans teemed with life forms that would become today's living fossils. Hydrothermal vents in the deep sea created stable ecosystems where species like the coelacanth first evolved. These dark, high-pressure environments acted as evolutionary cradles, preserving biological blueprints that defy time. Recent studies show genetic sequences in coelacanths are 90% identical to their Devonian ancestors, offering scientists a rare window into prehistoric marine life. In the Carboniferous period, horseshoe crabs developed armored exoskeletons to survive predators like giant sea scorpions. Their unique blood, containing copper-based hemocyanin that clots upon detecting pathogens, became a biological fortress. Modern biomedical research values this trait, using their blood for vaccine safety testing. Fossil records show their body plan has remained virtually unchanged for 450 million years, a testament to evolutionary perfection in deep-sea environments where predation pressure stayed constant. When the Permian-Triassic extinction wiped out 96% of marine species 252 million years ago, deep-sea trenches became biological arcs. Frilled sharks retreated to depths below 1,500 meters, where stable temperatures and chemosynthetic food chains allowed survival. Their eel-like bodies and needle-shaped teeth, optimized for deep-water hunting, show no evolutionary changes in 80 million years. Oceanographers recently discovered these living fossils near volcanic vents off Japan, thriving where most species perished. The nautilus, a cephalopod inhabiting deep Pacific slopes, demonstrates evolutionary stasis through its unchanged spiral shell. Its buoyancy regulation system, using chambers filled with gas and liquid, has functioned identically for 500 million years. Marine biologists found their growth patterns recorded in shell striations match those of fossilized ancestors. These time capsules thrive where environmental conditions mimic prehistoric oceans, cold, dark, and nutrient-rich from upwelling currents. Modern submersibles have revealed coelacanths inhabiting volcanic caves at 150 to 700-meter depths off South Africa and Indonesia. These living fossils exhibit identical fin structures to 400-million-year-old fossils, using lobed fins to walk along cave floors. Their slow metabolism, requiring only 12 hours of sleep per day, matches energy conservation strategies seen in Devonian-era fish. Satellite tracking shows they migrate vertically less than 50 meters, minimizing exposure to changing surface conditions. In 1938, marine biologist Marjorie Courtney Latimer discovered a live coelacanth in a South African fishing net, overturning scientific belief that these fish went extinct 66 million years ago. The specimen, named Latimeria chalumni, matched Cretaceous fossils down to its unique intracranial joint. Modern DNA analysis reveals they evolved 3 times slower than most vertebrates. This accidental discovery revolutionized our understanding of deep-sea ecosystems as repositories of evolutionary history. Remotely operated vehicles, ROVs, like NOAA's Deep Discoverer have filmed 6-gill sharks near hydrothermal vents at 2,500-meter depths. These primitive sharks, virtually unchanged since the Jurassic, exhibit slow-motion hunting behaviors unseen in shallow-water species. Their green eyes, adapted to detect bioluminescent prey, contain retinal tissues identical to 160-million-year-old fossilized specimens. Each dive reveals new species with ancient lineages, rewriting textbooks on marine evolution. Deep-sea warming now threatens living fossils adapted to stable cold conditions. Horseshoe crab spawning has declined 75% in Delaware Bay as sea temperatures rise. Ocean acidification dissolves nautilus shells, with pH-sensitive embryos failing to develop below 7.8 pH. Even coelacanths face habitat loss as warming surface waters push their prey deeper beyond their physiological limits. These species survived 5 mass extinctions, but anthropomorphic climate change presents unprecedented challenges. Marine protected areas now safeguard critical habitats like the Comoros Islands coelacanth reserves, Captive breeding programs for nautiluses at the Monterey Bay Aquarium have successfully hatched juveniles, though their 15-year maturation period poses challenges. International treaties regulate deep-sea mining near hydrothermal vents housing living fossils. Scientists advocate for evolutionary sanctuaries, deep ocean zones where these biological treasures can continue their uninterrupted journey through geological time. Living fossils embody Earth's extraordinary resilience, having witnessed continents shift and climates transform. Their DNA carries survival blueprints that may help species adapt to current environmental crises. As sunlight penetrates deep waters to illuminate a coelacanth's path, we're reminded that these ancient mariners predate dinosaurs, flowers, and even the Himalayas. Their continued existence challenges us to preserve not just species, but evolutionary processes that have shaped life for hundreds of millions of years.